In this video, it's sort of an introduction to chemical equations and writing them. Chemical equations are going to be a way that we describe a chemical reaction using formulas and other symbols. So here are some common symbols you're going to need to know when looking at chemical equations. On the top we have symbols, and on the bottoms we have the meanings of those symbols. This right arrow here, our first one, means that it produces or forms. And so in a chemical equation, this is what's going to separate our reactants from our products. And so in the middle there it says our reactants, and then produces our products. When we have multiple reactants or multiple products, we use this plus sign to show that there's more than one thing. This and this makes X, Y, or Z. These next four here in the middle are going to tell us what phase our items are in. The parentheses basically let us know that none of these letters are actually chemical symbols. They're just telling us, they're sort of descriptors of what the chemical symbols are telling us. So here in parentheses, the lowercase s means that that item is in a solid phase. The lowercase l in parentheses means that it's in the liquid phase. The lowercase g in parentheses means that it's in the gas phase. And this one is sort of an interesting one, but we use it all the time. This lowercase aq in parentheses means that something is in an aqueous phase, which basically means that it is dissolved in water. So these are going to be big ones that you're going to see a lot of the time. These last three are sort of special ones. They are letting us know if something that is not sort of a physical chemical is still being added to this reaction. For example, your arrow with heat over it means that the reactions are heated, so heat is added to it. Arrow with light over it means that they're exposed to light. So when you talk about photosynthesis, those sorts of things are exposed to light. When you see this ELEC, that means sort of electricity or an electric current is applied to those. So you should be able to recognize those, and I do think that these are a little bit self-explanatory. So, why use chemical equations and all these crazy symbols? Well, so instead of writing nickel 2 chloride dissolved in water plus sodium hydroxide dissolved in water produces solid nickel 2 hydroxide plus sodium chloride dissolved in water, that is sort of tedious. I definitely don't want to write that. I instead can write this. And it still says the exact same thing. My nickel 2 chloride dissolved in water, my aqueous there, let me do that in green, plus, and we have that plus symbol there, sodium hydroxide also dissolved in water, produces, which we saw before, my nickel 2 hydroxide, which is solid they mention, plus sodium chloride dissolved in water. Okay, and this is a lot simpler, and if I was writing this down on a piece of paper, it's significantly easier.